Howdy. Okay. Awesome. Okay, I think we are in fact live. Excellent stuff. Howdy. Says there's one person watching. That is excellent. If you're out there, please feel free to submit a question at thecalculustutor.com. I'm the stream should be displaying on there, and it looks like it's not. I'm working on it as we speak, as a matter of fact. But in the meantime, feel free to submit questions, jump in the chat. I just finished with a student, so I just had these, so I haven't had a chance to get myself fully set up just yet. Well, we're making it happen. I am checking my email for question submissions, check in the form for question submissions. What am I doing? Wrong button there. Once I get myself set up, I have some neat stuff to talk about. Students over the last couple of days have had some good questions. Sorry for no stream yesterday. That might be what has sort of disrupted stuff on the website. But given that I don't see any questions submitted, I don't think I missed anybody yesterday, so that's all right. That is just fine. Okay. Excuse me. First late night stream, and it's late 9. Okay. The student I was just meeting with told me they got 100% on their last math test. So that's pretty awesome. You like to see it. For any parents watching, I am, because this is right in the aftermath of that, and I don't have anybody in here just yet, taking advantage, and doing my post-session wrap-up stuff, which includes a message. So this is a high school student I was meeting with. So this includes a message to the parent with just a little summary and how it went and things like that. And so including that student got 100% on their test. Students did mention he's now in a rivalry with one of his classmates. Now that he got that 100%, his classmate didn't get quite 100%. Silly and ridiculous. I don't want to keep yawning through this. What's it, 7th? Nice. All right, let's get the Miro board shared. I lost that window there. Let's get this. Okay. There's that. Get the chat over here. Pop out chat. Oh, right. I still need to fix the website. Gosh darn it. I've kind of been referring to these as late night streams. They're not that late, but so apparently I'm very yawning. It's been a long day. Okay. So yeah, submit your math questions at thecalculustutor.com. Let me look at the website and see why it's not cooperating. And then we'll talk about submitting questions, and then we'll talk about some math. I have some math stuff that would be neat to talk about. Okay. Stuff's going a little bit slow. Oh, yep. I mess. Oh, yeah, do that. We do that. We do that. We do that. And we do that. Oh, almost. I forgot one thing. Son of a gun. Yeah, so it's displaying now, but it's displaying the wrong thing. Okay, one more time. Oh, well, let's grab the right thing, shall we? Okay, we got that. Yep, there you go. Perfect. And ta-da! Oh, I named the stream wrong, you guys. I named the stream wrong. I put the wrong date on the stream. I probably did. I set up on Sundays. I set up all my streams for the week, and I probably dated all of them wrong. I was probably off by a day on all of them. Maybe just type it on that one. Who knows? Oh no! I just type it on that one. No, not this one. No, come on. Excellent. Okay. Thanks for bearing with me while I'm just sort of doing some housekeeping stuff, hanging out with me. It doesn't. Let's see. I guess I should save this. And then I might need to fix the other page. We'll see. That's nice. The title change propagated really quickly. I think I am going to keep doing this Tuesday night stream as an opportunity. If this one catches on and like the after school ones aren't as popular, I'll add another late one. This actually is going to end up working really well for my Tuesday schedule, I think. Fascinating. The okay, okay, what is that? Weird. Okay. Okay. I think I got things patched. Okay. All right. All right. All right. Okay. Reloaded. Questions. See if there's anything come in. I am going to step away for just a second. But I will be back. Let me update the Miro board to reflect that. Ryan, right back. Boom. Boop, boop, boop. Yes, indeed. Ryan will be right back. I'm going to close this down, mute my thing. I will be right back. All right, and I am back. Hello. Hi. Get rid of that because Ryan is back, as a matter of fact. Excellent. I have a few things that could be good to talk about. I think okay. I'm asking a lot of my computer right now. The CPU is maxing out. Bouncing between just a lot of tabs. Trying to have a lot of tabs work, like do their work at the same time. Text in my system. So I have a couple of calculus problems that we could go through. But I think first I want to talk about interpreting absolute value inequalities. Just because that's something I've talked about with a student recently, and it's like a nice thing to like understand and know. And with the student, it's not how they're talking about in class. They're very process oriented in class. What are the steps you go through? But like, and that's useful. It's absolutely useful. And the sort of issue is with the classroom time you actually have. When do you teach the interpretation, or do you even teach it at all? Right? They don't need, I don't think, the interpretation to meet standards. So I'm sure like interpret is somewhere in the standards, but like that's, yeah, I understand the process of making it, excuse me, and delivering a curriculum. Um, so let's talk about um, interpreting absolute value. I'll put here inequalities. So the student had problems that were, well, I'm sorry. Also, today is obviously this is the first day I've done this late stream, and it's also the first day of just other stuff on my Tuesday schedule. Like I decided on some stuff, and that also helped me figure out what day to do the late stream Tuesday because of changes I was making to my afternoon. And anyway, all that said, I have not had the afternoon caffeine that I usually have. So I am feeling it. Especially with this being a late night stream, I am, if there's not people in here, if there hasn't been any interaction and there's like 15 minutes to go, I'm probably just going to end it early, because the after school ones, that's a different story. Somebody might be that might be the last 15 minutes might be the only 15 minutes they're able to catch because of the timing of it. I mean, I guess that could also be true with this one, but I'm so sorry. And I guess I want to start having some soliciting some feedback about like hours and things like that would work best for people. So the type of problem that the student was dealing with was they had to I forget exactly how. I guess I can look. Give me a sec. I'm forgetting exactly how the problems were phrased, but I can just look real easily. These are the directions, right? Solve each inequality and then write the solution set in interval notation. And specifically the types of problems. This is a straightforward version or example of the type of problem, but we can look at another one. So something like this. And so the student was actually pretty well practiced with the steps to get the problem from the starting state to the solution, the correct solution expressed in the correct notation and that sort of thing. Oh, give me 1 second. I'm sorry. I don't know if this is an everybody phenomenon or if this is just a Ryan phenomenon. But at night, my nose starts to run. I don't know why. Like when I'm sort of yawn, I also catch yawns really easy. Like if I just say the word yawn, that's really silly. Okay, so the student could get it from the starting state to the correct solution in the correct notation. He wanted to check in with me. There were a couple that were a little bit more complicated, but like he actually knew what to do. He just wanted to make sure he did. But then I started asking him about what these mean, and he understood what the absolute value bars mean, right? That the absolute value bars make things positive, but like, why do they make things positive? Other than that's just what they do, and that can be a fine answer. Like, what does a square root symbol do? It takes square roots. Like, so that can be a weird question to ask or answer regarding math symbols, but there is more to absolute values. So let's write some notes, shall we? And then we'll talk about a way to solve these non-algebraically. It's still algebraic reasoning. It's still understanding the algebra of it all. But when I say non-algebraically, just without taking those algebraic steps, do this to this side, so I do the same thing to the other side. Now I do this to this side, so I do the same thing to the other side until you get it to like x is by itself, right? That's the goal when you're solving an equation. But we can get to the solution without doing those steps by understanding what these math symbols are communicating to us. Because again, math is a form of communication and you can learn to read it. I can read this and understand what it's telling me about numbers. It's communicating a very specific idea. For right now, let's get our notes going though. So what do we want to remind ourselves of? We want to remind ourselves about absolute values. Absolute value is the positive, well, let's see, is the distance of the value from 0. This distance is always positive. Because we're talking distance, we just want to know how many units from 0 are you. We don't care what direction, right? So in terms of absolute value, 5 and negative 5, their absolute value is both positive 5. And there's a lot of reasons this is really useful. Right, and we can just like, if you if you're just running, let's say, right, you just need to run a mile or want to run a mile or whatever. You don't care. It doesn't make a difference in terms of running a mile if you run north or south or east or west. Now, in situ, right, it would potentially make a difference to me if I went east or west or north or south, right? We know sort of South Eugene is really hilly, right? So maybe if you're kind of close to South Eugene, you don't want to run south because that means you're running up hills, that sort of thing. But in the world of the number line, no direction is special or harder or right. So so it's just always a positive number. Just how many units did you move? Okay, so that's the core. And that's it. That is the core idea of absolute value. Distance from zero. It is not only can you always think of it that way, that is always a valid interpretation of an absolute value. We're going to look at this equation, we're going to extend that idea, or to look at this inequality rather, we're going to extend that idea. So if absolute value is the distance of the value from zero, then if we have something like, say, x, oh, oops, I said just x, but what I meant is the absolute value of x is, let's say, actually, I'm going to change it to less than, is less than, we'll say less than or equal to 3. Now, if this is just x is less than 3, well, that's pretty straightforward. We just know it just means, oh, this variable x, instead of being a specific number, which variables sometimes are, it's fine if it's a range of numbers, any numbers, so long as they are the numbers that are no more than positive 3. So positive 3, positive 2, positive 1, 0, negative 1, all the decimals in between those fractions, things like that. Okay, that's what just x is less than or equal to 3 would mean. What does the absolute value of x is less than or equal to 3? Well, remember, the absolute value just tells you the distance of a number from 0, and it's always positive. So, right? So if there's just a number in there, like -5, well, the absolute value of -5 is just positive 5. When we're looking at this, we're saying, okay, we want all the values x, we'll just call them all x, whose distance from 0, because that's what the absolute value is telling us, is less than or equal to 3. Right? So it's not just x that needs to be less than or equal to 3. It's the distance from 0 for all of those x values needs to be less than or equal to 3. So what numbers is that? Well, so we could do some algebra here to solve this. There is an algebra step. Oops, you're not following me. Hey, there you go. There's an algebra step we can take here, but let's think about it more intuitively. So here's 0. We want to be less than or equal to, it's okay if we're at 3, away from 0. Well, that could be 1, 2, 3 right here. Or it could be -1, -2, -3 right there. Those are both 3 from 0. We want to be that far or less than that far or closer. So it would be right here. Boom, but well, since we're doing a number line, let's do dots. Close dot, because it's or equals to, so this number is part of our interval. And that's as far away as we can get. And this is as far away as we can get. But any numbers that aren't that far away are part of our interval. So we'll draw a line between them. Or another way to say this is, it's messy, -3, +3 inside brackets. Right? And now we didn't even do any algebra here. Well, we didn't take any algebraic steps. The algebraic steps we could take, if we wanted to, right? We could do, so when you have absolute values and an inequality, let me write this. The steps you take, right? All of this stuff up here is still true, but the steps you take are you take whatever's inside your absolute value and you write it. You basically write the inequality exactly as it is. You just leave out the absolute value bars. But then so this accounts for all of the x values that are, say, that are above 0 but below 3. We need to account for these values that have to do with -3. So what we do is we also take this, we get rid of the absolute value bars, we flip, and we write down everything that's inside them exactly as it is, flip the inequality. If it's or equals to, you leave it or equals to, and then take the other side and make it negative. And now look what we have. We have the 3 interpretations of an interval. We have a number line from -3 to 3 and all the numbers in between. We have the interval notation, -3 to 3 inclusive, right? Brackets inclusive, or we have and now I could take this and write a compound inequality and make this like that. Oftentimes, though, we will just rewrite this. Oops, I wrote my inequality the wrong direction. As this. So in algebra class, you might be given this and told to solve it. But in real life, this is actually the notation we use, because all of this stuff, we want you to understand that it's contained in that notation, that this notation means all of these things. They're all just different. It's 4 different ways to write. And in fact, this is probably the most succinct way to write all of the x values that are no more than 3 away from 0. Okay, pretty straightforward. Now, this is almost like this equation, right? Except this one has a plus inside there. So before we tackle that equation, or that inequality, actually, no, I think we can go ahead and look at it. Let's, I'm going to move it just so it's not sort of distracting up there. And I guess I'm going to move the instructions as well. You know what I didn't do? I didn't explain how to submit questions. I'm going to get better at that. While I'm rearranging this really quick, hi, I'm Ryan, the calculus tutor. I answer math questions on stream. That's what I do. I would imagine a lot of like math homework questions that people have from school, but I'll talk about any sort of math you want to talk about. My hairband falls off a lot. That's a thing that happens. Exciting stuff here. And the way you can submit a question for me to answer in real time, live, right here, right? So you get, get your math questions answered. You don't want to wait. It's just it'll happen right now. You go to the, let me zoom out and go back up. You go to thecalculustutor.com right here, thecalculustutor.com. Now let's say you enter thecalculustutor.com into your browser. What's going to happen? You hit enter. What's going to happen? We're going to end up on this website. This is my website, thecalculustutor.com. You can see my stream is right here. Maybe this is how you got to it. So maybe you already know what this place is about. There's a submit a question button. Boom, right there. Submit a question. You wait for it, right? Loads and scrolls. Okay, boom. You can email me questions. Here's, because an email is open-ended, here's what to include. But what I'm hoping is the easiest and best way is the homework submission form, which is right now just a Google form because they're really useful. And if you click on that button to go to the Google form, this is what you'll see. Hopefully it might ask you to log into your Google account. You do have to be logged into a Google account to access this form because it allows you to submit files, and that's just a Google requirement. If you are logged in and it still won't let you access it, please email me, comment in the chat. If you're hearing me right now live, you can just comment in the chat. If not, if you're watching this afterwards and you go to access this, send me a question in between streams, and it gives you problems, go ahead and just email me, ryan@thecalculustutor.com. This form walks you through submitting a question, asks you how you'd like me to refer to you, name, pronouns if you care, where the question came from, what class, what teacher, a place for you to actually ask your specific question, right? Don't just tell me number 8 and send me a page of just all of your homework, a picture of just all of your homework questions. Send me the picture of all of your homework questions, tell me number 8, and then also tell me what your question about number 8 is. And even if that, and be really specific. So like if you were able to get started and you got stuck someplace, but if you weren't even sure how to get started, or maybe those problems don't look like the problems you did in class, that might be as specific as you can be, and that's totally okay. That just helps me know where in this problem you sort of are. Chances are I'll work through more or less the whole problem, but that helps me know where to emphasize and sort of where you're at. A little check. And then a place to submit images, clear and complete. So clear, the text is legible, like the numbers, all of it, right? And so I know this might be a little tedious, but I can't answer the question well if I can't read the problem. So yeah, take the time, get a clear picture. If the text, when you go to look at, when you look at the picture you took, if the text is small, zoom in and make sure when you zoom in that the text actually is legible at that scale. Oftentimes people send me a picture that looks good, but when I go to zoom in, I can't actually read that text. And then the other, also make sure you include either in your picture or as separate pictures, any instructions, like a separate block of instructions, like textbooks sometimes have, or like at the top of a worksheet or anything like that. And then any diagrams. If it's online, like in Canvas or whatever, feel free to take a screenshot and just send me a screenshot. And then clarify anything you need to clarify it where you ask your question, right? So this is the place for you to contextualize and ask me what your question is, explain the things you sent me. But remember, it doesn't have to be super, and especially if you're doing it live, then jump in the chat or be listening. And my hope is that you're willing to type in the chat in case I have a clarifying question or something like that. And yeah, right. And then the other thing you can send me that could be helpful is an image of any work you've done for that problem yet. That does help me see what you've done, how you're thinking about it, what process you used, especially as you move on in math. There's different ways to solve problems. So that can be helpful. You don't have to send it. If you do send it, I won't share your work on stream, so you don't have to worry about that. And if you don't mind if I share your work on stream, and that can be instructive for other people, I won't. This doesn't guarantee I'll share it, but like maybe. Feel free to check this box, but you're under no obligation. If that box is not checked, and I work on the assumption this is an opt-in thing. So like I work under the assumption that you don't want me to share your work. And if that box is not checked, I won't. It just won't happen. Even if you really wanted me to, even if he's telling me in chat, nope, you didn't check the box, and that's my agreement. So, okay. So yeah, feel free to send me stuff. Pictures. You can attach up to 5 pictures to the form. I hope I assumed that would be enough. When you email me, I think it's kind of arbitrary how many pictures you can send. I think there's a maximum like file attachment total size, but yeah. So yeah, if you go back to the website, if you trouble, then just email me, ryan@thecalculustutor.com. You can either click this or copy paste it, and the guidelines are all the same as the form. How to refer to you, name and pronouns, where the problem come from, teacher and class, your specific question about the problem, and your clear and complete images to go along with it. My hope is that it's pretty quick and straightforward, but also it would be submit just one question at a time. If it's like a whole group of questions, you're like, our teacher didn't go over how to solve like any of these types of questions, that's fine. You can send them all to me, and then I'll choose some good like example ones from your work to just use. And then if the stream is slow, I can do a few of them, and that's fine. Yeah, in between streams, feel free to submit stuff and I'll answer them on the next stream, and then that VOD will be available. because you're either emailing me or sending me that form which collects your email address, I'll be able to message you back and send you the notes. Oh, speaking of which, I'll send you a link to this board so you can go in and look at the work I did, and you can move around and you can go look at all the other stuff too if you want. It'll be read only, so don't worry, you won't be able to like break anything or anything. So yeah, scroll around, see what's on here, look at more than your one problem if you care. Yeah, that's how this process works. It seems pretty straightforward to me. But I understand that there's complications that I can't foresee. And I have not at all been able to test a student Google account. So like the local school district, 4J, uses all the students in the district have Google accounts through the district. And sometimes those Google accounts don't play nice with other stuff that's outside of the 4J Google system. So just let me know. Send me an email instead. And if at some point I get word that form isn't working with school email addresses, I'll problem solve it. I just need to know what the issue is, or that the issue exists at all, in order to know what I need to pursue as a solution. And I just don't have access to a 4J student account to try to like access the form with. Oh, I totally do though. I have 4J students. Why don't I just have some of my students test it? Okay, I'll do that. That will be good. Okay, so anyway, we were talking about this. I was moving this problem down so that we could move on to talking about this one and say, okay, how does having this +4, what sort of difference does that make for us in terms of our interpretation of this? So x plus 4, anytime you see a variable and then stuff done to that variable, until you know what number you're plugging in, the result of that is also a variable, an unknown value, right? So this x plus 4 right here, that's just as unknown as x is. So we have an unknown number that we have the absolute value of an unknown number that we want to be less than 9. We want to be within 9 of 0 when this is equal to 0. But when is this equal to 0? Well, when x equals -4, right? We can subtract 4 over. We can do it with an algebraic step, or we can just say, oh, what plus 4 is 0? -4 plus 4 is 0. And so regardless, we get x equals -4. And so instead of us being centered at 0, distance from 0, now this is actually distance from -4. It says x plus 4, but it's distance from -4. So this is, and we want that distance to be less than 9. So we can interpret this as all the numbers that are within, right, less than, within 9 of -4. So we can go to our number line, and instead of putting 0 at the middle, we're going to put -4. And then we're going to do 1, 2, 3, 4. Oh, actually, let's do -1, -2, negative. Oh my gosh. did that backwards. -3, -3, -2, -1. There's 0. There's 1, 2, 3, 4. And there's +5. That is 9 above. We also want to go, so that's -4. There's -5, 6, 7, 8, 9. There's -10. That's 6. 11, 12, 13. Oh, I should make that bigger. -13. There we go. So that's a distance of 9. This is a distance of 9. And this is a distance of 9. And we want all of the numbers that are in between there, specifically within 9. So we don't actually want -13 or 5. So they need to be excluded. So we're going to have an exclusive interval here. And now we can take this and say, okay, well, how do we write all of these numbers? Well, so we can do the number line notation, right? So we can say an open circle here at -13 and an open circle here at 5 because they're not included. And we want all the numbers in between, and we just connect them. Or we could do an interval with a parenthesis, -13, comma, up to 5, parenthesis, so exclusive. Or we could write a compound inequality. We could say -13, we want x to be strictly greater than that, and we want also x to be less than 5. So we could say that. But again, the more efficient... Oh, are you following me? You are following me, except it's behind my picture. Sorry about that. There we go. Again, the sort of succinct way to write that, though, is x plus 4 is less, the absolute value of x plus 4 is less than 9, right? But we can look at this and understand that it's communicating all of these things. Like I can read this and say, oh, this is just telling us all of the numbers within 9 of -4. So there's the 9. But how would I have known to say -4, right? And this is, notice we're dealing with x values and we have a positive, but we have to interpret it as negative. And there's this weird sort of flop between positive and negative when you're dealing with x's. This is going to come up again. And we'll dig into this phenomenon, but it will keep happening in math, right? That when you're dealing with x's, you have to sort of reverse the positive negative in these sort of weird ways. I don't want to say too much specifically about it because I just want you to look for it, and we will talk more in more detail and in more depth about what is actually happening there. And it's all the same thing that's happening. Yeah, I feel confident in saying that. It's all for the same reason. Suffice it to say, because I know how to read this, we can actually come up with a better way to write this. And so here's our notes. So here is interpreting an absolute value inequality. So first of all, we're going to say if you have an inequality that looks like that, then we can interpret this as all x values. I'm just going to say values because x values and value, x just means variable values. So all values that are within B of A. And now this is exclusive because it's an exclusive. If it was inclusive, then it would be up to B away from A, right? instead of just strictly within. So that whether this is or equal to or just a strict inequality, that just determines you're inclusive or exclusive, whether you're including or excluding the endpoints with brackets or versus parentheses. So that all stays the same. Okay. Or so this is kind of the version we talked about, but we could also do x minus a is greater than b, and that is all values at least b away from a. So that means go above a by b, go below a by b, just like the previous one. But instead of wanting all the values that are within those two sort of endpoints, above and below, you want all the values that are beyond them. You don't want any of the values that are in between them. You want to be at least that far away. So all values at least be away from a. And again, if this was or equals to, it would be b or more away, right? At least be away from a. That's it. That's our interpretation of these absolute value inequalities. That's basically what I was building to. Really quick, let's take. Are you still following me? You are. Let's take this one right here, and let's rewrite it in this form. Notice it's x minus a, and why is it minus? Well, minus in mathematics, subtraction is the operation that finds distance, right? If you want to know how far apart two numbers are, how far is 10 from 0? Well, 10 minus 0 is 10, so 10 is 10 away from 0. Or 10 minus 5 is 5, so 5 is... I keep choosing numbers that I have to say twice. 10 minus 6 is 4, because 6 is 4 away, right? So subtraction finds distance on the number line. And so if we wanted to take this x plus 4 less than 9 and interpret it more easily, we might actually write it as x minus negative 4 is less than 9. Now notice what this does for us. It gets the minus, so we know that we're talking about a distance here. It also exposes that negative 4. So remember when I read this before, I said, oh, I can read this and say, oh, this just means all numbers within 9 of negative 4. But how did I know it was negative? It says positive 4. Well, it's because I know that actually to interpret this, we want it to be subtraction. Well, if you have addition, but you want to write it as subtraction, you just write minus a negative. And so we can actually see, I'm going to just write this a little bit nicer. 4, there we go. This is, we don't really like to leave things like this though, right? Like back in, I don't know, 5th grade or something. I don't know when you learn about negative. I don't remember when you learn about negatives anymore. You might have had a practice problem like this that said to simplify it, right? X plus 4 is the simple way to write this. So we'll write this, and we can still interpret it this way. We just have to do a little bit of the minus and negative stuff in our head. But you don't have to do it in your head. If you're working on a problem like this, you can absolutely take a step where you're like, nah, I see what's going on here. I'm going to rewrite this so that I can actually see what this number is. Do stuff like that. That's doing stuff like that on paper. Going through the process of doing it is how you get good at doing it in your head. I can do all sorts of math in my head now because I did all sorts of math on paper once upon a time, and still continue to do all sorts of math on paper. Even if I could do it in my head, sometimes, especially if you're like in the middle of a problem and you just need to do like a multiplication, but that multiplication is like a tiny part of the overall problem. It's often easier to just do that on a calculator or do it on paper really quick than try to do it in my head while I'm still trying to hold on to the other stuff, the process of the problem or whatever. So yeah, you get good at doing math in your head by doing a lot of math on paper. You also, once you can do math in your head, though, that's not always the best way to do it for the problem you're trying to solve. Sometimes, so yeah, I know, like young people who like math, like particularly young people, like elementary school. But this thinking holds on for a while, and even into an adulthood for some people. This thinking that I totally lost my train of thought. I'm so sorry. Taking the opportunity to refresh and see if there have been question submissions. Often think that the goal of getting good at math, or that getting good at math means learning to do or doing more and more math in your, not even just learning to do it, but like people who are good at math do lots and lots of math in their head. They do most of their math in their head. And that's just patently untrue. Most people who are good at, who like do math for a living, do especially the important work on paper. Nobody can see inside your head. And oftentimes the end result is not the most important thing in math. The process is highly informative. So being able to do stuff on paper is important. And I would argue being able to do stuff in your head is like less important, really. And it's actually difficult to work with people who do most of the work in their head and commit very little to paper, because I can't access that, right? So they're sort of gatekeeping their knowledge. And if you're trying to collaborate, that's just not helpful. It doesn't help you move along, right? So anyway, all of that to say, take the little steps you need to. Write little things in the margins. Definitely write the formula you're using. Don't just flip to the page in your book or in your notes and look at it. Write it down for that problem. You need that same formula on the next problem. Write it down for that problem too. What that's going to do is help you memorize, keep that formula fixed in your head, but not just memorize the symbols and of the formula and the order they're in and stuff like that. It's going to help you remember when to use that formula, right? And that's the trickier bit. So it's one thing to remember what all the formulas are and be able to just write them all out from memory. It's another thing to understand when you're supposed to use which formulas and for what things. Writing the formulas down in the problem that you're using them in helps you associate this formula with this type of problem. So yeah, write stuff down, I guess, is the point I didn't realize I was setting out to make, but I now realize I am in fact making the point. Math is communication, so math should be written down. Resist the impulse to do as much math as possible in your head. You will learn more, you'll get more out of math, and you will be a better math communicator, and therefore better at math when you write stuff down. Especially because when you write it down, you have to conform to the sort of norms and notation of the people you're trying to communicate with. But that's the whole point. Again, math is communication. So you have to communicate in a way other people can understand. And oftentimes that's a thing that people who do a lot of math in their head, they do struggle with that communication part, because people think differently. Like the process of thinking is different for some people. Some people think in words, some people think in images. For some people, when they're doing math in their head, they can like sort of mentally picture the symbols. Other people don't picture the symbols at all. It's more about the numerical relationships, and the symbols exist on paper, but in their head, it's more like, it's more about the relationship numbers have to each other, and then all sorts of other stuff. And so that said, when you're doing a lot of math in your head, you are really, really practicing doing it your way, which is great. I love it. I want you to develop your way to do math. However, it is equally important that you're also practicing the common parlance, right? Practicing using the symbols correctly, the notation correctly, the vocab words, right? I hated vocab words when I was in math class, right? I was like, this isn't English class, this is math class. Why are we studying words? Right? I was one of those. So I people who say or feel things like that, I get you. I understand. Um, Math is a specialized form of communication. Any specialized form of anything is going to have its own vocab that you need to understand so that you can communicate with the other people who are doing that thing. Now, granted, all of this, if you're not particularly interested in math, you're just trying to get through a math class because you need you need the grade, uh, but you don't necessarily feel like you need the knowledge or the skills, um, then that's not particularly inspiring to you, I would imagine, because you don't plan to talk to people about math. You're only ever forced to talk to people about math in math class. Um, I will say, learning these things will make math class a bit more enjoyable. It will, because you will understand what's happening more. You will be able to have those conversations more easily, and you'll feel more comfortable in them, even if you don't enjoy them and you don't have plans to enjoy them. Being able to be in the class without discomfort um, is powerful, is useful, right? And now, granted, there's all sorts of reasons, other things that might be causing discomfort in the classroom, and I encourage you to talk to your teachers about that, or share them with a parent or somebody who you think might be able to help. Um, Heck, at some point, this could end up being a space where we can all collaborate together to help each other solve like school problems, right? Like right now I'm focused on the school problem of math homework and people having math questions, but like that's what I'm focused on right now. That's the start. The goal is to be something that just helps people feel comfortable at school, right? I know math is something that causes a lot of stress, and it's something that I understand very well and feel like I can help other people understand pretty well, quickly and without too much pain. Um, oh, sorry, my tablet just flashed, but it's just giving me a low battery. Sorry, I lost my train of thought as I got distracted by that. But suffice it to say, uh, that's what this is ultimately here for. Take math, which is something I know lots of people struggle with in school, a big school struggle. Create a spot for it. But if we're solving that problem, we can solve some other ones at the same time. Because lots of people are experiencing this, like, if not the same, at least similar struggles when it comes to school. We all have our special, unique pain that is just ours, but oftentimes it overlaps in ways with other people's, even if it isn't identical to theirs. You're like, oh, this little bit is kind of like yours, and this little bit's kind of like yours, and we end up having a lot of shared things. And so, since a lot of people, have this struggle is a little bit part of their experience, well, if we accommodate that, or if we help with that struggle, well, now those people all have just a little bit less barrier, a little bit less hardship in their life. And it doesn't solve everything, but it's a start. And then we can turn our attention to some other thing. Oh, and now if we solve that, Now that's a little bit that's off for a bunch of people, and then some people might have had both of those things, and now there's double, right? And so you just do it a little bit at a time, figure out what our shared struggles are, try to address those, listen for people's unique struggles, because those are hard to deal with, right? Shared struggles are spread out, right? And you can split stuff up, or you can say you do it on you deal with it on Tuesday, I'll deal with it on Wednesday. Unique struggles, personal, those are tougher. Oftentimes they're invisible. And other people don't necessarily know how to help. When you have a shared struggle, you encounter somebody else, they're like, oh yeah, well, I've been dealing with that for years, so here's how I do it. No, that's kind of similar to how you do it. Oh, you do it a little bit different way. Maybe I can learn from that. But that applicability is less clear sometimes for our own unique personal struggles. But we can do a similar thing with those. We can say, well, okay, what is one aspect of it? Can we do anything about it? Can we ease it in some way? This is here to ease the math part of it, and as a building block, a step to start seeing about what other shared and individual and unique struggles we can help each other with. That's the plan. That's the goal. Do it after school. Do it at night. Do it on Sundays, 11 to 1. So this is basically done. I haven't got any other questions. I only went over the absolute value thing, and I'm fine with that. I will probably talk about the calculus stuff tomorrow. In between questions, I'll probably talk about those other calculus questions. Yeah, I'll be back tomorrow after school, 3:30 Pacific time. I'm trying to think if there's anything else. I mean, I don't think so. We will. I guess I'll go in and get stuff on my site all updated for tomorrow. That's a nice thing to do for myself. Maxing out my CPU. It's not something you like to see 100% on. All right, there's that. This is loaded now. So we will swap out the video feed for tomorrow's. If I can find it. There we go. Nope. There we go. Excellent. Homepage updated. We'll do the stream page and then we'll call it a night. Yeah, I'm gonna try to. I didn't stream yesterday. I'm gonna try to keep the missed streams to a minimum, but sometimes it just is not in the cards, you know? What in the world? What is happening? Oh no! Oh, I made the son of a gun. 35. I made the little streaming block on the streaming page disappear 30 minutes early. That's so silly. Well, one of these days I'm gonna get the kinks ironed out of this. But you know, it's not going to be in the middle of the third week. All right, there's that. There's that. So I believe website is corrected. So sharing, turn that off. And I will say good night. I think I'm going to keep this schedule next week as well. We'll do Tuesday will be the night stream, 9 to 10:30 again, and then Monday, Wednesday, Thursday will be the regular after school streams, and Sunday will continue to be an 11 to 1 sort of chill Sunday stream. Cool. I will be back tomorrow right after school, as expected. Submit your homework. You don't have to wait until the live stream starts. You can submit your questions early. Submit them anytime at all. So yeah, I will see y'all tomorrow. Have such a good night.